All right, everybody, welcome back to another OpenShift Commons briefing with the
Hello,
folks,
everybody.
the good folks from the GTO office. We have Andrew Clay Shafer here with us and John Allspaw from Adaptive Capacity Labs and other incantations of himself. And today we're going to talk about learning from incident, which
Incidents.
it's incidents. Okay,
I
incident.
wish we could. I wish we could only have one.
Only one incident, yes. Well, 0 accidents this week in my household. How about yours? So I'm going to let Andrew and John introduce themselves, and we're going to have a rolling conversation here today. So no slides, um, and go for it. Andrew, take it away.
Yeah. So I've talked to you before, and I'm not sure I want to talk too much about myself, but I will talk about myself a little bit to introduce John. So the thoughts that I have, around some of the things regarding DevOps and operations were definitely influenced by this man, John Allspaw, and the way that he got to be part of some very, we'll call them generative projects, and gave a talk that I would say essentially gave DevOps the movement its name. So there's this famous talk from Velocity Conference where John Allspaw and Paul Hammond talked about Dev and Ops cooperation at Flickr, and that like chain into a bunch of other things led to a bunch of conversations about DevOps. He was a big part of Velocity Conference. He also wrote some books, and now he's really focused on and very passionate about this notion of learning from incidents and human factors. And I'll let him introduce himself a bit more, and then we'll chat about that.
uh, Thank you, sir, Andrew. Yeah, I mean that's a great intro. I have to say that I've learned as much from you, Andrew, as you might have learned from me. Yeah, that's about right. And really, at the highest level is on my mind and my colleagues' mind are introducing new ways of looking at how work gets done. And one of the most sort of effective ways of looking at how work gets done can be seen by looking closely at incidents.
So just really quick,
Yeah.
not necessarily as a pitch, but explain what you do at Adaptive Capacity, and that'll kind of lay the.
Sure, yeah. And so what we do at Adaptive Capacity Labs is help organizations. It's a small consulting group, help organizations understand how they learn from incidents currently, who learns, where that learning travels or dissipates, and how to glean more and richer understandings of their incidents, to help them do what they're already doing, but tends to go sort of unnoticed, and that is preventing incidents. And a great deal of doing this work means bringing a sort of a host of pretty particular techniques from from research into human factors and cognitive work in other domains. But none of those techniques and methods are new. They're just new to being applied in the software domain, in the way that we do that. From time to time, worth mentioning, from time to time, organizations will experience a significant event, something that's really visible. So it's sometimes advantageous for them to hire us to do the analysis ourselves. A really bad oversimplification, but I'm going to say it anyway, is you could think of one of the things that we do is you've heard of the NTSB in the U.S., whose role is accident investigation in aviation and other transportation fields. You can think of Adaptive Capacity Labs as helping build mini NTSB expert, a cadre of people inside your organization who have NTSB like skills and expertise that they currently don't have. That's a short way of saying it.
Let's reify this a bit. When we say incident, what we're talking about is the website is down. or something along these
I don't
lines.
I don't know actually, as it turns out, and maybe what you've teed up for me here in an incredibly veiled way is that turns out the definition of incident is not as crisp and standard and clear as we might think. Um, as we know from looking at real incidents, incidents don't always show up with a big label on their forehead that says "I'm an incident."
So,
Even working out whether a thing is
so
an incident, it can
yeah,
be of
a few
interest.
a few weeks ago, Kat Swittel was on talking on another one of these sessions, and she brought up a slide that had a picture of like in a factory floor of 0 incidents in the past 365 days or whatever. And basically, the anecdote she was telling was whenever she saw something like that, it panicked her a bit because
Yeah.
that meant they weren't watching for something or they were missing something because there's just like really no way that there wasn't something that they could learn from these incidents. And so I think the definition of incidents is has lots of different semantic meanings in different ways. So I think that's a key piece of the conversation.
Indeed.
I don't know where you want to go with it, John, but keying off that and this notion of what considered an incident is also in some cases a question of blame, right? So like or attribution,
Mm-hmm.
causation. So I know you have lots of thoughts on this, so maybe
Yeah.
you could give us a little monologue about some of these things.
Yeah. Well, the first that I think I actually like what Diane had brought up, and so I'll riff from that vantage point. Um, so like I mentioned before, a lot of what we do is bringing new perspectives to understanding what makes work hard and what makes people good at it and what makes them what could potentially either support or hinder their ability to do work. The majority of the techniques and perspectives come from sometimes called safety critical domains, like power plants and medicine and military and transportation, all that sort of stuff. We have to remember that categorizing, remember even declaring a thing that happened, an event, as an incident, right? Labeling it as an incident is itself a categorization. The notion that that there's really only two, it sounds cartoonish, or at least I hope it sounds cartoonish to a lot of the viewers here. But quite often you'll hear, okay, in the wake of an accident, you say, okay, well, is this a result of human error or technical failure, right? For whatever reason, the journalists just one of those two categories. That frame, that what makes an incident, what makes not an incident, is sort of beyond the scope of this. But as a bit of a trivia, a man named Heinrich in the early 1900s put together this notion that you could characterize, and by that even declaring a thing an incident or not, and even human error or technical failure. And that was his sort of contribution. What's not often brought up is that he worked in an insurance company, and so having a perspective on a categorization is a political as much as genuine curiosity. What stems from this is exactly what you just mentioned, Andrew, which is blame. And blame certainly gets a lot of attention because it's sort of palpable. It's telling the story of human error or making it about the individual attributions of a particular person. This is the root cause was Stephen, right, or something along those lines. Is really just a special version of
Even again?
Yes, Stephen. Again, exactly. And Lisa had to bail him out once more. Um, the um, the the notion that we have uncertainty, and in that matter, sort of an uncomfortability, in the wake of an accident, meaning a thing that has some form of surprise and adverse, effects or whatever. To think, one, because that came out of nowhere, otherwise it wouldn't be a surprise. In some way, it came out of nowhere, right? But to admit that those things in the future are possible, and the sort of ever-present dread that they can't all be anticipated, means that we have to put this sort of fear, this general, like, oh my God, how can I feel good about the future, even if it's a lie? I'd rather feel good, right? And so where can I place this tension? In the case of blame, I can put it in.
We get uncomfortable with uncertainty.
Yeah, well, yes, exactly. And in particular, we want a place of, we want to hold up a totem or some form of, just put a place, scapegoating, pile the sins of the village on the back of the goat, and send the goat out of town, right? Is the way. So we need to put it in a box. Notice I didn't say container. We have to put it in a box, and sometimes that box is embodied in a person. Sometimes it's in a really big, vague. It's in the system, man. Or sometimes it's in or your cloud vendor, or as long as if there's a place to put the uncertainty, the underpinning this is the developing an understanding of the incident.
So
Can be.
Yeah, aren't you missing just a little piece though? Because, or I'm sure you're not missing it, but because there's always that phrase that failure is where the innovation comes from. So when we put things in a box or a container, whatever, and
failure is also where you stop looking, in a sense. I want to make one quick comment that I think might help the listeners, which is John and I have spent hours and hours talking about some of these things over the last 10 years. And I think that it's in our best interest to articulate that these quote unquote systems are neither human nor technical. It's socio-technical, both of those things together. And then also add, and I think this is relevant to the OpenShift community, there is no organization on the planet running any of these systems that thinks that the systems themselves are fully autonomous, and that their reliability is not dependent on the actions of those human entities and agents to keep the reliability.
Yes. Well said. I think we've probably spoken on the order of days, Andrew, on these topics over the years, in total.
We're also getting old.
Yes, we are. A big part of taking taking some of these perspectives can be somewhat mind flipping, actually. So Diane, you mentioned, you said something about, failure is sort of where innovation happens, which is undeniable. One of the things that I've come to understand in a really deep way is something that's quite unintuitive, which is that success is, understanding how people are just plain doing their work. It can also be a significant source of innovation, right? You can think of many products in the world, very, very successful businesses that turned what was otherwise a workaround in a previous product into a significant and really groundbreaking service. I think of CDNs. It's a great example of that. And so but the difficulty, and this is the difficulty with the field of resilience engineering, is that you have to, I can't just say, all right, everybody, at the end of the day, let's get together and let's talk about all of the ways that the site could have gone down but didn't, right? Because there's not enough time. We'd be there till the next day. And so, and this reflects in the same thing of safety, right? The denominator in Kat's slide, it's a great example in the world of safety where you see those signs, and those signs actually are in a number of places. Notice the denominator's missing, which is one. It takes for an account that an incident is all incidents are the same. It also doesn't count how many incidents were prevented. It only shows the ones that were there. And Eric Holnagel has said that when you start measuring things, Holnagel being a sort of pioneer of resilience engineering, when you start measuring things by what is not there, you run into some difficulties. You can certainly prevent a lot of scores on goal, but if you're not scoring, then it might not end as well the way you think.
You have a pithy
but again,
for resilience engineering.
Do I have a pithy? Okay, yeah, improvised. I would say that resilience engineering is the study of both. Currently, is the study of, that is to say, adaptive capacity, investments in adaptive capacity, playing out in real world situations, standing on grounded and concrete empirical evidence. Resilience engineering, the engineering of resilience, stands on understanding what resilience looks like to begin with. It's a field, it's a domain, it's a community, and it's 20 years old, at least, and but it's only maybe 5 years old, with software and technology starting to bridge and understand those. Not very pithy.
Not very pithy. I think, I mean, one of the interesting side note is there's things that were emerging in practice that were gravitating towards what you just described as resilience engineering that definitely predate the 5 years that you're giving it the label.
You're absolutely right, and that is the thing that was fascinating. The reason why I was able to, when I became first interested in this, did my master's degree and started continuing reading. When I contacted the heavies in that field, it was Richard Cook and David Woods and Sidney Decker and Steve Shorrock and others.
So this should probably have come out in the introduction, but just for the listener, walk through how you got there, right? So you run these websites this way. Kind of tell us a little bit of that arc to where you gravitated towards that field.
Sure. So I worked at a photo sharing website called Flickr, as you mentioned. We were acquired by Yahoo, but for the most part, we were sort of our own sort of standalone sort of entity, and we grew in ridiculous ways. I mean, in cartoonishly atmosphere, stratosphere ways. We went from being the 25th most trafficked property at Yahoo to the 5th most trafficked, behind the front page and mail, right? And in 18 months. The complexity of the back end of the website, all of the things that made things work, just kind of exploded. And at some point, I had a team of about 6 infrastructure engineers And at some point, we had some big outages, some pretty significant outages, but I couldn't get over the fact that on paper we should have had way more, and I couldn't understand what that is, what's that about. And actually, some of these, having been sort of part of responding to some of the incidents, after you work out the incident, and all incidents can be really harrowing. We kind of like, okay, aftermath. Okay, wow, that was bananas. That was crazy. It's like, yeah, it's kind of crazy that we even worked out what was happening. Like, yeah. And so I couldn't, as a manager, I was thinking to myself, okay, what's going on here? Either I'm incredibly good at hiring, and like being able to do this work is sort of innate, you're born with it or something or whatever. I just happen to strike gold with the people on my team, or they were certainly pretty good and I'm an amazing manager. And that's what, like, so both of those are completely unbelievable. Certainly the latter one would have been existentially difficult to accept, because I had have no idea what I did to make that. So I started to look into, like, what underpins people's ability to solve a problem, not just solve a problem, but solve a problem under time pressure, where any of the actions you're taking could very well make things worse, right? And represent in definitely cautionary tales, an existential business, situation. And that's what led me to human factors. And what I understood about human factors is this, field, most of us understand ergonomics. Ergonomics is quite often seen to be a sort of a specialized sort of subset of the field, or if you're in Britain, you'd say that was the field and human factors is the subset. But the fact of the matter is, where technology, work, and people, happen is this field. What I realized was something happened in about the 70s, and part of human factors, traditional human factors, started to undergo a sort of again, an existential sort of, wait a minute, we actually don't understand this stuff the way we think. 3 Mile Island was the point. The whole planet that was doing human factors work was like, holy crap. No, actually, you can't design an operations room without taking into account the cognitive work, not just like plain old, can you see the dials and all that sort of stuff. And cognitive systems engineering sort of was born. And it's a very, I wouldn't call it a splinter, but certainly it's a field in and of itself. Don Norman, Dave Woods, Jens Rasmussen, these are folks that were almost entirely came from nuclear research in nuclear power plants, but then went on. And to this day, even though resilience engineering as a field, resilience engineering is a pretty broad field, because it's got a lot, it's entirely, there are sociologists, there are operations research, there are statisticians, there's lots of people. A core part at this juncture is cognitive systems engineering. It's not all of what represents resilience engineering, but certainly a core part of it. Much like, statistics is a bit of a part of computer science, or, and mathematics. So these things sort of interrelate. That's a little bit of my, background of how I got there. And I'm still learning, so that's the gist. The final thing I'll say is that it is much more rewarding, and the thing that I am excited about is that much like continuous delivery, continuous deployment, the notion, all of the things that we associated with that, both the things that enable it, the rationale for even thinking about it in those sense. There was nothing that there was nothing special about that 2008 2009 timeframe. Like, all of those ingredients had been set up. You could argue that extreme was was pretty much the thing that tipped people down that road. But it's like one of those things when you look at it, like, oh, yeah, it seems so obvious in hindsight. And it was pretty straightforward, small and frequent changes for this reasoning, and you'd need these to do this. Sort of straightforward, but there's a perspective shift. I mean, I think my guess is that both of you were there to sort of see this perspective shift. Light bulbs go on. That's what's happening.
The perspective shift is not evenly distributed.
You're absolutely right. You're absolutely right. And so, yeah.
So how does when we talk about resilience engineering and cognitive systems engineering, can we talk a little bit about the work that how you applied that, maybe not at Yahoo, but afterwards and stuff, and tease that out a little bit? Because the thing that actually sprung into my mind was how we tried almost to automate that in software with things like Chaos Engineer, Chaos Monkey, and things like that, which doesn't take into consideration the human factor at all. It's just like, it tries to simulate it, but there's no human. It's like running test after test after test and doing this crazy to your website and stuff. So like, can you pull that up, tease that out a little bit more?
Yeah. So actually, I'll comment a little bit on what you just mentioned with respect to chaos engineering as kind of an example of how sort of application could look. So myself, Nora Jones, Casey Rosenthal, there are and others. Matter of fact, there's a new book from O'Reilly on chaos engineering, has pointed out actually that the certainly one perspective is the one that you described. Another perspective is that the creation of a chaos experiment, the process and practice, the dialogue that generates where, how, when an experiment ought to be performed, can be as valuable, if sometimes even more valuable, than actually running the experiment. In which case, this is a capture of cognitive work.
Mm-hmm.
And so what I would say is, matter of fact, actually, because I was just reading. Let me just read this here. Nora Jones, this is in an interview that Nora gave you. Jones also states that before and after of running a chaos experiment is as important as running the experiment itself. And so how does the application of cognitive systems engineering look? Well, I'd say the first real sort of application was in my master's thesis, which is to understand what rules of thumb or heuristics engineers use when trying to resolve and understand and respond to outages, especially when signals, as we know, can be disparate, sometimes contradicting, sometimes not make much sense. When faced with an entire sea or almost infinite number of places to look, you start looking somewhere. What leads you to look in some places rather than other places? And so this is the study of cognitive work. My thesis, which you're happy to download in case you're having difficulty sleeping, will sort of go into detail there. I would say the significant work is if I were to give you a couple of threads to pull on. If you were to look into methods, techniques, approaches, it's an entire family of things that make up what's known as cognitive task analysis. Cognitive task analysis is more or less the formalized method with related cognitive work analysis, CTA and CWA. And all of these tips and tricks that go into that is the application of cognitive systems engineering. You can think of those are the tools to understand how people understand and how people wrestle with, both cooperatively in teams and also individually, problems that they're facing, problems that they're anticipating, and what those problems in anticipation or in responding to, what they mean. And what comes out of that is this closer look. And that what we always like to say is, look, the expertise is coming from inside the house. There's much more, there's much more to understand about how people do their work than is represented in JIRA.
I would add there's a tendency in all of these practices, especially when you're kind of outside of the core conversations, to focus on the tools, because you see it as a concrete representation of what's happening. But in my mental model and the conversations I've had with some of the people you just mentioned, I feel like the core chaos engineering community and the stuff we're talking about with cognitive engineering, resilience engineering, like those are essentially inseparable in my head.
Yeah, absolutely. And what's exciting about chaos engineering is not only the original, a lot of the sort of, proponents, even the earliest proponents of chaos engineering, are seeing this connection, and they're seeing this connection in ways that is, for me, really satisfying. And they're making new connections that is between resilience engineering and chaos engineering that I wouldn't have even seen. And so that's really satisfying. Super happy about that.
Someone just dropped something in the chat that reminded me of some of the stuff I've seen you talk about before that might be fun to articulate here, which is this notion of the kind of the lines of our models and how the process of incidents and analyzing them helps us build clearer models. Speak to that. Interesting points.
This notion of this line of representation, it's a bit of a mind blower, right? So and this is entirely from the worked out in the Snafu Catchers Consortium, and is described in a lot more detail. I'm not going to be as eloquent here, but in the Stellar report describes this sort of frame, and the frame goes like this. We have all of the stuff, the technical. We've got the databases. We have, we've got the thing that we build. Here's the thing that generates, that users use it to generate revenue. Here's the stuff that we build and maintain to help us build that thing, right? And here and all of the things that sort of intertwine with that, including like dependencies and all this stuff. So we've got all this stuff that sort of fits together: databases and code repositories and networks and firewalls and all of this stuff. That stuff, we manipulate that stuff. We do things with that stuff via a representation of that stuff. It's not with the stuff, right? When you go to make a schema change, you don't go to the data center and do a thing physically to the database, right? And so everything we know about that world is via these representations. They're not the things. They're representations of those things, right? Distributed tracing app is a representation. To the extent that it's useful, it is a representation. It's not the thing. It's not it's not the thing that you hold. You can look at it and say, oh, well, there's that. And what that means is that people's ability to not only make changes but also anticipate what the system might do in the future, and where it came, and it is based on where it came from. It comes from nowhere except for their mental model of the world.
the work we do is both facilitated and limited by these mental models that we've built up about what we're working on.
Yes, exactly. And so what should surprise, and in addition to that, what incidents and what close study of incidents shows is that no one has the identical mental model of the same, but this below the line stuff as others. They may have some that are close, they may have more detail in some areas than others. And what's happening is that teams are continually recalibrating these mental models through discussions with others, through looking at dashboards, looking through code, writing new code, seeing how that behaves, and that it's in this constant recalibration. So we have overlapping mental models, and so what's surprising is they're never complete, they're always faulty in some way, and stuff works almost all the time despite that. And the reason why it does is because only people can adapt and recalibrate that mental model. It's not the stuff below the line. It's not there's no intelligence that goes down there other than what has come from us. And it's not the below the line stuff that's doing it, right? It's our ability to make sense of what's happening, what's happened in the past, what's happening right now, what makes that matter, and what might matter in the future important to pay attention to. And so that's the notion of above the line, below the line.
So and to go back to something very early in this conversation, the blame game. And I come from a perspective of open source community development and trying to shed sunlight. And so when there is an incident, and we have one team has their mental model of how things are working, one of the things that I try really hard and is very hard to get people to do is to share their model. It's almost a cultural shift because often it's inside, it's something that went wrong with a product or a service or something like that. Flickr went down, or somebody went down, and they're very reluctant to have an open dialogue with the user community about what went wrong, because then maybe they'll shift to another service provider or something like that. So there's this, and I'm just wondering, maybe from both of your perspectives, how you help companies and organizations understand that putting some sunlight on your mental model or your models might and exposing them, sharing them with people, and how to do that effectively and allow other opinions, because going back to where the innovation happens is those aha moments of, oh yeah, often come from outside perspective. So
I want to add, before John goes back to answering the question for real, that this occurs at several layers and levels as well. So internally, there's often, and this is, people talk about job security or whatever, people will protect the mental model that they've constructed and not share it internally. And then that, also happens between teams, between departments, and then, as you mentioned, externally. But at the same time, I feel, in the Velocity conference and the community around DevOps Days and the rest of that over the last decade or so has essentially started making postmortems or incident analysis publicly into an art form. So I'll let John make his comments on that. But this this isn't just between the organization and the outside. We protect our mental models on several scales.
Yes, and to the to your observation, Dan, that there can sometimes be reluctance, right, to giving. I wouldn't say sharing mental models, because I might make a point about that, but really even just really relaying any sort of information about what was happening for them at the time, right? Yeah.
Doing a public postmortem on something that's a public service outage or something like that. Often there's huge reluctance from engineering teams to do that, and that's
sure.
Good
but
reason sometimes.
well, I mean, I mean, it is right. If they believe that they would get something from it, they would do it. If they believe that, and this is internal and just like Andrew said, and external. There's nothing. There's some peculiarities about write-ups about incidents to the public, but remember those are the purpose of those, the audience for those is very different than an internal, right? And to mistake the two as being similar is different. The point that you brought up, which is reluctance, I mean, there's a reason why that people are reluctant, right? If they think that they can get something, if they think there's something positive and they feel supported in giving a story, then great. If there's something that is potentially threatening for them or others, then they won't, right? And so remember and just the somewhat of a potentially nitpicky point on mental models is that I can't ask you for your mental model. You can't give it to me. You can tell me a story from a cognitive technique. When you ask somebody something about how they rationalize, right? Something called reflexivity, you will give the answer that you think that the asker, the requester will give. You have to build a constellation of data that supports this mental model recalibration, and you have to, and that's both a mixture of records of what people do, what people say, and what people do and say about what they do and said, including others. This is called process tracing, but it's the way that you can make ever valid inferences about cognitive processes. Sorry to get really nerdy there for a second, but this is the reason why this is what makes doing this work difficult. People won't share a thing that they think everybody knows, or they aren't even aware of themselves. A famous researcher in the late 60s said it quite best about tacit knowledge. We can know more than we can tell. And a significant part of studying cognitive work is exploring tacit knowledge. And there are some ways that you simply cannot do it. And you have to learn and practice how to do that. Otherwise, the results aren't valid. And there's only one thing worse than a really poorly captured incident write-up. And that is an incident write-up that everyone, despite its contents, finds to be non-credible, because the authors and the methods by which that was formed is seen to have an agenda. The effective incident analysis requires an analyst to be a non-stakeholder. Full stop. Full period. There is no other alternative. You need to have no stake, no dog in that fight, no horse in that race about what the analysis does other than provide others a boundary object, a source of dialogue.
Isn't that exceedingly difficult to have no agenda?
This is why Adaptive Capacity Labs is an expensive professional service. If it was easy, we'd already be doing it. What's the difference between? There's a reason why, and I'm going to be super blunt here. The world of human factors. It's been said, many colleagues of mine now have said this. The origins of cognitive systems engineering human factors, all the stuff that we're talking about, definitely cognitive task analysis. The reason why a lot of this comes out of research in the military, DoD and DOE funded projects in the U.S. and other parts of the world, is because of consequences and time pressure. And it's jokingly said that you're doing this work either because somebody who was supposed to get killed didn't, or somebody got killed who shouldn't have. And that wipes away, consequence and time pressure wipes away anything else that is immaterial. That's what makes incidents. That's the Trojan horse. We think, that it's a myth to say that using these techniques, looking into incident analysis isn't there. The focus isn't necessarily to find what broke. It's not some sort of socialized debugging. It's to find out how stuff works at all. The incident is just a director of attention. The incident is just the filter. And you could think of an incident as your system saying, hey, everybody, listen, you really ought to come pay attention. There's something, this doesn't work the way you think it does. You should come, right? It's incredibly efficient. It's very efficient in that way. And so we're just
opportunity. It's the opportunity.
Yeah,
You see the incident as the opportunity.
Exactly. And to that, I would say, people who don't have the skills on how to do it are only going to get so much out of spending an hour in a conference room filling out a template. Sorry, slightly snarky. But
the other thing. Go ahead. Well, I was going to say the other thing is that a good incident report or a good postmortem doesn't necessarily tell you what caused the incident. It just gives other people information that they can help you sift through, and maybe sparks a conversation that gets you to that opportunity.
Yes, and in order to do that, it needs to be compelling for the broadest audience in the deepest ways possible. Mm-hmm. Engineers need, and I mean, this is something we know about software engineers. They don't read anything they don't think they need to read. And when they think they need to read something and they have an expectation they're going to get something out of it, you're damn right they're going to read it. And so doing that, capturing what makes incidents hard, capturing what makes, red herrings and wild goose chases happen because following those have worked in the past, right? But you very rarely see the details of red herrings and what made red herrings so attractive to follow in incident write-ups. Very, very, very rarely do you see that. That's an example of something. That's an example of the messy details. That's really important.
The other outcome of doing postmortems and incident reports is also building trust. When you share that information, you're building trust with the other folks across silos internally or your end user community that you're sharing this information, as opposed to withholding it and not exposing, the things that might have led up to it. So and the hardest thing is to do it well. And I think
this is proportionate. And you're right about trust, but that trust is proportional to the quality and what others find of interest in the report, right? Mm-hmm. Which is why I'd say a very strong signal, not the signal, but a very strong signal, is how many people read. How many people read it? How many? If you can't, and I'm going to go out on a limb. I know that counting and doing statistics on how often somebody has visited a web page is a solved problem. I know of a company who's built their entire business on that. But yet, if the way to break trust is to make available all your incident write-ups that are terrible.
Hmm. And it's a
right?
skill to do good ones. It's a skill, and it shouldn't be done lightly.
Yeah,
So
you know,
Well, I think in a lot of organizations, it's a mandated perfunctory action, and that's I think the
yes.
part of the problem that John's trying to expose. That we're kind of coming towards the top of the hour, and given the fact that not everyone has John Allspaw on retainer at this point, what kind of practical advice would you give to someone listening about where to start, where to explore? What can they do that would make some maybe meaningful changes to their own mental model, not necessarily about their systems, but about this type of work.
Yeah, that's great. For the record, if everyone was interested in having me on retainer, certainly please reach out. Uh, the so that is a great question. So there are two things that I would suggest. The first is to understand that there's a growing community who is it's not just Adaptive Trust Labs, right? There's a website called Learning from Incidents. You will see reflected in a lot of blog posts more and more people talking about these topics. I'm happy to sort of tweet much more. I'll say that the Learning from Incidents page, and in particular, Lauren Hochstein on GitHub has written an absolutely stunning sort of a set of resources about resilience engineering and understanding cognitive work that you can look at. Pragmatically, practically, a couple of suggestions. The first is to make effort to capture from as many people as you can what was difficult. Ask them. Put it in a news section in your postmortem template or wherever you want it, and get people to write what was hard, what was surprising, what was difficult. The more people, not what they thought the team thought was difficult, not in an abstract way, individual perspectives, individual perceptions. What was hard, what was difficult. The more that you can, and lots of things are difficult. It's not just, sometimes even understanding the thing that you're seeing is bad can be difficult. And so gathering those sorts of reflections, right? Every engineer has this feeling, this sort of, when we talk with organizations, I'll ask, have you ever about to run a command? You're responding to an incident. You're about to run a command, and everybody thinks you should do this, right? All your colleagues are like, you should do this. This looks like it's the best shot. Okay, all right, I'm going to do it. Have you ever had that feeling that right before you hit enter, there's an equal chance that this might make things worse?
Well,
right?
on a regular basis.
That's a palpable, extremely important experience that almost never finds its way into these narratives. Capturing what makes work hard, what makes work harrowing, absolutely astonishing. There are surprises that are absolutely fundamental, right? There's this notion of a situational surprise. That's when you buy a lottery ticket and you win the lottery, right? And then there's fundamental surprise, and that's when you don't buy a lottery ticket and you win the lottery. Okay. Fundamental surprises are what make Chernobyl, they make the BATS IPO, they make Knight Capital, they make a 3 Mile Island, they make accidentally sending a ballistic missile alarm to the entire state of Hawaii. And so capture that. That's my pragmatic advice. Capture that stuff. Put it down. People will read it because they've been in that situation. What do you think about that?
I think I could sit and talk to you all day.
Me too.
Always.
Well, We'll definitely have you back. I think there's a piece that I'd also like to tease out is because, and again, Andrew's like maybe focused on organizational change and transformation and DevOps stuff, and I kind of have I'm trying to figure out how to apply this to some of the open source communities that we're helping support, because doing this in open, transparent processes as opposed to maybe in an enterprise process, which is very, very important because I'm sitting inside of good old Red Hat, and this stuff happens all the time, and we do have a great engineering team, and they have read all the books, and they've done, and they actually apply a lot of this stuff, so it's great. It's been wonderful. But then when we take it and we have to do it in the open,
Yeah.
and when I talk about sharing that, how we do this in an open, positive way, and learning the practices in open source communities, which is something that now that I've read the books, and now I've heard you speak, and I've heard Andrew speak, and everybody's is trying to figure out how to take this to the open source community work that we're doing. Very
Sounds like
a
that
challenge.
sounds like that sounds like an amazing and excellent challenge. Excellent topic.
Well, cool. And we are at the top of the hour, and we're going to hit a button soon and end this conversation, and that's going to make a fundamental issue for all of us, because we'd love to.
It doesn't have to end the conversation. You can reach out to us on LinkedIn or Twitter or what have you.
Yeah, and
We'll
I'll try
continue the
and
conversation, but we'll just end it for the day.
yeah, and I'll try and find many of the references that you spoke of, the both of you spoke of, and add them to a resources page for this conversation when we post it up. And definitely have you back again. And boy, lots of things to think about now over the weekend and ongoing. So thank you very much for joining us today.
I'm very happy to talk with you, Diane, and I always love talking with you, Andrew. So thank you so much.
We all do. Yes. Thanks. Take care, guys.
Stay safe out there.